Okay, so today we are going to focus about the client utilities of DNS. So the utilities that you can use to troubleshoot a DNS issue, okay, or to find out how your DNS server is performing. Okay, there are few commands, namely one is called as nslookup, which you would have seen in Windows world as well, and there is a command called as dig, and there is a command called as whois. Okay, and there are many more. So these three are going to be the most essential commands that you will see around in your when you work in the DNS environment. Okay, so first we will focus on nslookup. So nslookup is a command which by default will return you a record info. Okay, if I say nslookup www.google.com, it will straight away respond back to you with the A record info of the query that you post. What is an A record? It is a name to IP resolution. Okay, so this is a default mechanism, but there are many other options that are available in nslookup which can help you get multiple other things. Like if you press nslookup and type www.google.com, is going to be the same output. So what it is saying here, it is saying server is 192.168.1.1. it indicates this is the server to which your client machine is asking the query. Okay, and this is the address of the server including its port number to which your query was sent, and it has responded back with this info. Okay, which is also very similar here. Okay, but what you see here is like it says it is a non-authoritative answer. So when an answer is called as when you see an answer which says non-authoritative, it indicates that your DNS server did not go to the authoritative DNS server to give you an answer. Okay. It says when you see a non-authoritative answer, it says that it is giving an answer from its cache. Okay. So in most cases, 99.9%, you are not going to hit a specific DNS server to get a value. In most cases, it is going to be a cache response. Okay, so in most cases you will see a non-authoritative answer. Okay, you will see an authoritative answer only when this particular DNS server hosts the zone that you are requesting for. Okay. Okay, so I said that nslookup by default only returns back the A record info, but you can also change the record query that you are going to send to it. So if I say set type equal to ns. Okay, so what this states is that if I type the same www.google.com now, it is going to return back with the ns record info of my query. Okay, so it is not going to find the A record info of it. Say, okay, so but what happened here is I asked for a record info and I have set a type as ns. Okay, so in case I have typed google.com, this would actually fetch me the ns record info, because here I have asked for a zone. But here I set the type as ns, but I asked for a record. Okay, so it responded back. Maybe this is the zone that you are looking for, and this is the guy who can respond back. So this is actually your SOA record that it has turned back to you, because the query that you asked was not done zone info. Okay, so now I see it is giving me the name server info of Google. Okay, so if I want to query this server instead of querying my server, what I can do here is I can say server, and then I can type in the server name to which I should point my query. Okay, so now all my NS queries or any query will be pointed to this server, and then answer will be asked. Okay, so I now say set type equal to A. Okay, and then I type www.google.com. it is giving me an answer, and all these are actually the authoritative answer that you have obtained from the server, because that is the actual server that is sending you things. So likewise you can set up many other things, like type equal to SOA. I type yahoo.com and I see the,
so it will show the authority of,
yeah, so it will show you the authority of that. But now what it is saying, it is saying it is not can't find the server can't find the yahoo.com refused. Why? Because ns2.google.com is a name server which hosts the google.com zone, and this name server is not a recursive server. Okay, so it hosts the zone of Google, but it is not a recursive server. So when you ask it a different question, it is not going to go to internet to find an answer. It is going to respond back to you only if it has a record within its zone. Okay, so now I change back to my own previous query, and then I type the same yahoo.com. Now this server, this is my ISP server, this server is a recursive server, so it will go through the internet and will try to find the answer. Okay, so this is the SOA record of our yahoo.com zone. Okay, understood? So this is about nslookup, the primary functionalities that you would like to use on nslookup. Okay, so few things that we found is like, one is nslookup by default will have an a record answer. Okay, and you can also set the type of question that you are going to ask, like, and you can also set a server to which you are going to point the answer, you are going to point your query. Okay, so by default DNS queries will run on port 53 UDP. Okay, and port 53 UDP cannot be tested using tools like telnet. You cannot say telnet ns2.google.com space 53. This will not work because telnet cannot work on UDP. Okay, so you need to use one of the tools that I listed earlier to check if a DNS server that you are pointing is working. Okay, so the next command is dig, which comes default with Linux. Dig is like, it has multiple other features.
So you should not use a telnet for checking the DNS.
No, yeah, for checking DNS query you cannot use telnet. For you're going to test FTP or you're going to test NFS, there you will be able to use telnet to see if the remote port is open. But since DNS is working on UDP 53, you cannot use it. Okay, but DNS also uses TCP 53 for what? For the zone transfer between client and the master. Okay, so I say dig, which is also going to be the same thing, and I say www.google.com. okay, so dig, you can use it something like this: dig followed by the URL that you are looking out for. Okay, and you can also use an @ symbol to focus your query to point to a specific DNS server. Say for example, I am pointing to the Google's Open DNS server, and my query is going to be pointed to this particular server now. Okay, so that is the server that is going to respond back to me.
Suppose dig
www.google.com.
So I supposed to know the DNS number.
This part, the last part, you need not know. Say I am trying to point to a specific server. Only I'll point only to the server that I know. If I don't know a specific server, I can just type in my default DNS server in my system will be taken from the file called as what? From the file called as etcresolve.com. Okay, it will go to etcresolve.com to find the name server, and then it will use it to the query. Okay, so I'm just showing the other way. So if you say www.google.com and point it to some server, it will go and ask that specific server. So this is a recursive server that Google has put onto the open internet. Okay, so when I type this, it is going to give me an answer. Okay, so this is the output that we have seen. Okay, and it is saying the version of dig that we have used to run this, and then the URL that we tried. It also says what we are doing, what is the error status that we returned, okay, what is the query that we sent, how many answers have been replied, and is that a authoritative answer, and there is also an additional entry that was given. It is also saying me the query time, the server that responded, all these information including what I requested for. Okay, so dig will give you all the information possible in a single command. Okay, And dig can also do one more thing, wherein it can when you press trace, it can also go through the entire recursive process. It will trace to the root servers, and then it will trace to the NS servers on each step by step. Okay. Okay, so we saw dig plus trace, okay, which will trace to the root servers and get you the value. There is other command that I told you, which is called as whois. Okay, so when I say whois, www.learn@ace.com. Sorry, there is no domain called as learn@ace.com. Okay, so it will give you all the information that is available for this particular zone. I'll refresh the screen and type it again. Okay, I need to type in only the zone info. Okay, so say when you type in whois, it is going to give you all the information about that particular zone. Okay, so all the info that you have registered while you create your zone. Okay, and it will also give you the name servers that this particular zone is hosted. Okay, so and whois database is the total database that your registrar stores onto the COM servers or the top level domains. Okay, so this will give you all the information that you entered during your registration process. Okay, this whois will be essentially useful when somebody comes to you and says, hey, you are the owner who has to own this zone, and I know that it is in your DNS server where this is hosted. Consider you are a DNS service provider. Okay, and your client is saying, I know that I hosted this domain with you. You should not say that it is not with you. So one thing that you can do is run and dig or nslookup to point to NS record, or you can also type in whois, which will also give you the owner or the registrar to whom you worked and who registered it, all the info. Okay, so let us say I'll say whois nike.com. Okay, so when I type in the zone, it is going to query it, and it is going to come back to stating this is the name service that is hosting it, whoisonline.com, and this is the name server, email, and this is the location, phone number. These were the things that were given when this was registered. So everything about the DNS zone can be seen using an whois record, whois query. Okay, so essentially we have seen three commands. One is like nslookup, dig, and whois. Okay, so understand one important thing, the process flow. Okay, so understand the process flow that happens. Okay, consider this is your server, and you ask for google.com. Okay, so you need to know what happens first. What it will do is it will go to its file called as etc hosts. Okay, so it will check under etc, and it will check for the etc host file. Okay, and then after etc host, if it is found on the etc host, it is going to take that name resolution, and if it is not there, it is going to go to what file? It is going to go to etc resolve.conf to see what is the DNS server. Okay, so it is going to go to resolve.conf and see where do we point to the DNS, and then only then it is going to go to the local DNS server. And if your DNS server has a recursion enabled, it will go to the internet world and it will fetch your data back. Okay, so this is the process that happens, okay, on a client machine. Okay.